John Jensen
啊
，John Jensen，
，John Jensen，
你没听过这个人吗？JenJSAN，S-E-N。
延伸了
啊，
延伸
对对对，你应该听过吧？
没有，多时间
那凹凸性就是他发明的。
哎，赵瑞没有来啊，赵瑞没有，他是不是有一点 GG 了吧？
可能还又不懂，很遗憾。但是这个看他应该是没有来了。
他的三好像有点问题。这样大的，
老师，我可以记住你
啊，记住我。没发生。OK， Okay, hello. Hello, you here? Have you prepared any question for tonight? MA. Yeah, if you want, but after my class. Okay, actually, I really want to talk something related to your MA. It's about a quantifier statement. Let me start first, and then I'll collect questions from you. Huh? Okay, so let me ask you a very simple question, a logic question only. Very important. So, S is a car. Can you decide whether this is true or false? Oh, why not? What is X? What is X? If X is cherry, is cherry a car? Yes. You know cherry? You guys know cherry? You don't know? Let me find for you. 什么 bread 烂掉？讲看，展开说说。I don't know. I never know. 被踩断掉。This one, do you see this color in SMUM or not? Cherry. I thought this is a China brand. Is this a China brand? Yes, right. Cherry. Cherry is a car. So cherry is a car. Huh? Cherry. Chery. Is a car. Okay, well, sure. Mercedes is a car. Okay. How about CHRRY? Leh? Is what? It's a fruit, so it's not a car. So meaning what? This sentence with variable is true or false depending on x. Okay, so this is not a statement that we like in mathematics. We want a statement either true or false, but not both. Okay, so this is not a kind of statement. But if we add in, for example, a quantifier, then this is a statement that we can always say true or false. So if I put for all x, there exists an x such that x is a car, is true or false? Huh? True. Why? Huh? Why true? That exists. So let me put an English here. So the English is what? There is a car. Is there a car? Is there a car? Who is the driver here? What driver? Driver. 驾车的人会不会驾车？ Who are drivers here? Do you have a car? Do you have a car at home? Is this statement true or not? Huh? Is this statement true or false? Hi, Ling An. There is a car. Is it true or false? No, this is not how you read English. There is a car 是很可爱的你们。So 这个 there is not place. Okay, this is equivalent to say there exists a car. 中文比较准的翻译是什么？存在一辆车，没有哪里。There's no places here. This is not places. There is 存在。嗯 ？What do you mean? There is 有存在。Okay, it's not places. 有吗 ？True or false? 是小月嘛？小月是吧 ？There is a true or false? Why? There is what? That's a kind of word. Can you give me an example? In the parking. I also give one example, right? Cherry. Okay, good. What about if I change the quantifier for every x, x is a car. But I think I pick from somewhere. For every let me pick from somewhere. Where's a good place to pick this x? How about for every non-human object in XMUN? X is a car. True or false? Zhao Seng. False. Why false? Huh? Cat. No, I pick from non-human. Oh, non-human. Okay. Okay. Change. Non-human too easy. Non-living good. Non-living object. Non-living object. 来再选一个 true or false? 招生 still true or false? False. Why 呢？Okay. So table is non-living, but not a car. So in this case here, table is a counter example, but not a count. Okay, table is a counter example. Understand or not? Is it clear? Is it clear? Okay, so one more thing I want to emphasize on proving these two kind of statement and assuming these two kind of statement. For all x, px, and there exists an x, px. Okay, any one of you seen the post I put on your group chat or not? About the logic clinic one. Any one of you read it before? I made an analogy to Tom and Jerry. Anyone see it before? In your group chat, team group chat. Some of you seen it, some of you didn't. Okay, let's talk about that one. I want to talk about these two differences, proving and assuming is really, really important to understand how to prove a statement and what to produce. Okay, how you make assumption to them. So let's take a set. Okay, a set of mouse in this world. So let's name it M. So in this world, there are, let's say, only three mouses. So we have Jerry, we have Mickey Mouse, we have Rat, maybe Ratatouille if you like. Okay, so let's say, let's look at this statement here. So the claim is there's a mouse hit by Tom. Okay, so this is a claim. 我被打了，怎么证明你被打？ How do you prove it? How do you prove the claim? How do you prove this claim? Sorry? How to prove it? Huh? Give example. So, what could possibly happen? Huh? Maybe Jerry get hit. Okay. If Jerry get hit, then you are done. If Jerry not get hit, yeah. Yeah. Okay. So what's wrong with that? Okay. So if Jerry got hit, then done. Okay. So Jerry get hit by Tom. How to prove? Because he got he got an and what sick leave, not sick leave. He get what record? What kind of record? Medical record from the doctor. Okay. Let's say if Jerry not get hit, can you still prove this claim or not? How can you prove this claim? Huh? Sorry? Maybe Mickey Mouse get hit. Okay, you prove that Mickey Mouse get hit. Why? How do you prove it? Because he said so. And I saw Tom hit Mickey Mouse. Let's say Jerry, Mickey Mouse, and Rat all not get hit. Can you still prove this claim or not? Then this claim is false. If let's say Jerry and Mickey Mouse both get hit, is this statement still true, Lina? Why? Yeah. Why? No. I already assumed they get hit. So is this statement still true? Is the claim true? Why? 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 If Jerry and Mickey Mouse both get hit, is this claim still true? Why? Huh? Mm. Mm-hmm. Good. Okay. As long as there's one of them get hit, this statement is already true. Okay. But let's say there's a theorem. Mouses that get hit must admit to the hospital. Second claim. There is a mouse in the hospital. How to prove the second claim? Assuming claim one we already proved. Jerry got hit already. How to prove second claim? By claim one, what happened? Jerry got hit. And then by theorem, Jerry has to admit to the hospital. Claim one and Jerry is in the hospital. Okay, but could it be possible that Mickey Mouse is in the hospital? Could it be possible? 宇轩，有可能吗？ Is it possible? Mouse 也在 hospital 里面，他们成为病友，有可能吗？啊，有，怎么可能？怎么可能？谁这一点？哦，如果他受伤，他就要去。Mickey Mouse maybe 受伤 ，OK， 因为受伤，哎，我没有讲受伤，我是说被打哈，被打哈。OK，maybe Mickey Mouse also got hit as well. Maybe you also prove that Mickey Mouse got hit by Tom because he saw it, right? Because he said witness it. Okay, so Mickey Mouse can be also in hospital. Okay. Okay. Okay or no? But right. I mean, it's good that we know that Jerry is the mouse that got hit. But does it matter if I don't know the identity of this mouse? Does it matter? If I don't know the identity of the mouse? Matter or not? 那个韩星后面那个叫什么？那位同学，浩瑞，浩瑞。Does it matter？如果不知道那个被打的猫的身份，这句话还成立吗？啊？为什么成立？Why valid? Why still valid if we don't know which mouse get hit. Uh, 不完整这个答案，再换一个。If we don't know the identity of the mouse, we don't know whether Jerry get hit, Mickey Mouse get hit, or Red get hit. Is this claim 2 still true, assuming claim 1 and theorem is correct? It's true. 懂我在问什么吗？True or not? If it's true, why? 为什么？来翻旁边那个叫什么来着？苏瑶，能帮忙一下吗？要先讲我，好，不要转移注意力。来，是，因为 claim one says they exist. I don't care which one actually, as long as they exist. If you know which one is quite good, but don't know, also never mind. As long as they exist. Okay. Okay. Okay, so this is existence. How about for all? Let's say claim 3. Actually, 我问了他们，原来每一只都被打。All mouses get hit by toe. How to prove this? All mouses have to prove. How to prove all mouses? Okay, good. Like Lydia say what? All mouses is in the computer. Sorry. Hospital. Hospital. But okay, look at this theorem here. This theorem only got one direction. Get hit must admit to hospital. Does it mean that those get admitted to hospital must get hit or not? If then implies, if P then Q implies if Q then P or not. Maybe it just sakit perut. You know what is sakit perut? Diarrhea. Diarrhea. Maybe diarrhea go to hospital. 不是吃太多垃圾食物了 Too many rubbish food. Okay. So not very good. So how to prove? We know that Jerry get medical record already, right? Okay. And then Mickey Mouse, I witness it. Then what do you need to do? You just need to check what happened to who? The rat. Okay. You just need to check what happened to the rat. Okay. Maybe Jerry got hit from the head. Maybe Mickey Mouse get hit into the stomach. Maybe rat get hit into the leg. So leg injured. Due to okay, so you need to check one by one. You need to check. Okay, one by one you need to check. Okay. Does it make sense? Okay, you need to check one by one. Okay. One by one you need to check. Then we can put a corollary here. All mouses are in the hospital. Okay, by claim 3 and theorem. Okay, so I mean, if we want to prove this, we also can do it, right? Prove it one by one. Okay, Why Jerry is in the hospital? Because Jerry, what happened? Get hit by Tom. And then, by theorem, admit to the hospital. Similarly, Mickey Mouse and Red all get hit by Tom, and then they have to be admitted to the hospital. Okay, you have to check one by one. That's why sometimes you say take arbitrary epsilon. What does it mean by take arbitrary epsilon? You fix that epsilon first, and then you check that something is true or not. Or you take arbitrary sequences that converge to X, and then you check that whether it satisfies property that you like. Any question? Maybe later we'll discuss the assignment and then I'll let you see something. Some writing by you. I haven't finished marking. I'm halfway doing it. Okay, one more thing before we go to a real question. So how do you prove statement like P implies Q? Sorry, assume P and then prove Q. You know why you do that? 为什么你那样做啊? Why proving this implies assume P prove Q? Okay, I'm gonna teach you a way to read truth table that you never read like that before. Okay, so what is the truth table for P implies Q? Let me set out the table first. True, 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 false, false, true, false, false. So P implies Q is what? What's the truth value? True, false, true, true. You see, you want to prove P implies Q meaning what? You want it to be true. How many instance it is true? There are 3 instance it is true. If P is false, actually you don't need to care one. It's always true, the whole statement. Okay, if P true, Q true, the whole thing is true. So the only thing you need to worry about is the second line. When it can false. When it can false. It is when P is false, P is true, Q is false. Then the statement will be false. Now you need to avoid this. 因为你要 P implies Q 是对的，你不会让它错。就这一个项会让它错吧。Only this situation here will make your P implies Q false. You need to avoid it. Avoid false. So how do you avoid? You assume P is true, and then Q has to be true. If Q false, then the statement is false. Okay, so that's why you assume P, and then you assume P is true, and then you prove that Q is true also. Only then you can avoid this F. Okay? 有问题吗? Okay. Okay, right. So these are the logic. Make sure you get the logic right. Otherwise, you'll read a lot of mathematical statement wrong. And then you don't know what to assume, don't know what to use. Okay, any question from you? Before, let's do assignment first. Okay, let's do assignment first. I think this time the assignment is so far okay, but I still found plagiarism case. So if you make sure, if you borrow your assignment to your friend, right, please ask them to understand and then write them themselves. Okay, otherwise you'll start receiving my email. All right. So our first question here. You can try and follow the discussion and then look at your own solution. After I return your marking, If there's any problem or dispute, you can come and look for me. All right. So our first questions prove that if the domain group is cyclic, then the codomain group is cyclic also, and also if the domain group is abelian, prove that the codomain group is also abelian. So let's start from the first one. These two proofs have the same flavor here, which you need to use surjectivity. Okay. Surjectivity is how to use. A lot of you forget the definition of surjectivity. What does surjectivity do? Surject means what? You can hit everything in your core domain. Okay, so this is the main point you need to use it. So part A says what? We want to prove that G prime is cyclic. So meaning you need to find a generator. So who is the generator here? My claim is if X generate G, then phi of 5 of X will generate G prime also. Okay, so how do I do it? So I want to show it generates G prime, right? What do I need to do? I need to show that every element can be written as a product of dx only. So this one is a proving for all or there exists? For all. So for all, what do you need to do? I need to check every element. So what do? I just pick any element from G prime. Anyone. Okay. And then by what? By surjectivity, there is an element in the domain. Let's call it G now. Get mapped to Y. So Y equals to 5G. But G is in a cyclic group. Meaning what? I can write this G as a power of X. Okay, so there is some K in Z such that G equals to XK. So some of you when you write K in Z you don't have this for some I take marks off. I take 1 marks off. You don't quantify your variable. Okay, this is what we discussed just now. If you don't quantify your variable, your sentence might be true or might be false sometimes. Okay. So you need to put variable here. This is there exists some. Okay. Then what can you do? You can realize that if I use the property of homomorphism, how do we get? We get y equals to 5x to the power k. But what's the mistake you guys think? Most of you, what you did was, we know that G in G is cyclic. So G equals to xk for some k. And then you just do phi of G. Phi of G equals to, you use homomorphism, phi of k. And then you deduce that G is generated by phi x. 一房有错吗？一房，你觉得这样子写 ？Do you think it's correct or not？ 就这一个部分。Can I deduce that G is cyclic in this way? So let's take any G. 你觉得对还是错？不用紧，错不用紧的，你觉得对还是错？你觉得错？为什么错？哪一步错？会有错哪里错？后面是意涵吗？后面那个，你叫什么？子豪，子豪嘛？子豪，你觉得对？你觉得错吗？为什么错 ？OK， 答案是错。为什么错？知道吗？后一个呢？冰下，来冰下，尝试一下。 不知道。一行诶 ，sorry， cannot see， 可以搬来前面几个，前面很多位，我不知道，sorry。你没事 ？lonely 是什么意思？不懂。啊哈。OK，yeah，right。全部人有听到莉迪亚讲什么吗？莉迪亚讲到是 ，you cannot hit everything in the codomain. So what can you deduce here? This should be G. G prime. You can only deduce that phi of G is generated by Px because you only look at the image. Okay, so I mean in the diagram of the group, you only show that phi of G is cyclic. But how about other element inside G prime? 明白吗? You only look at the image of G only. You see 你看这个步骤you take a G in domain and then you apply phi. That's not what you do. This is the image. You only look at the image. Understand or not? The thing, the thing, sorry, the thing you look at is just the image. So what's the difference here? So many people confused with pure max is like this. You see that, in my step, I also got phi g equals to this. Here also phi g equal to this. It's the same or why you say different? This is the difference of pure max already. How do I argue first? I first take everything inside G prime first. But in this mistake here, do you take everything inside G prime? No. You start with everything inside G. And then you apply phi. Okay, so this is the image of G only. Okay, so you just look at image of the group domain. Okay, but what we do is we take a Y here, okay, and then we make sure that it is generated by, so we take any random Y here, okay, we show that it is generated by Px. This is what we do. Okay, but in the mistake, you only look at the image. Jasmine, no question? Any question? Feel free to ask. Understand? If no question, do you understand? Also no understand. So you have to ask, figure out a question to ask. Because I don't know where you start.洪瑞洪瑞，可以解释一次吗？中文也可以，英语也可以，混的也可以。请各位会华语的同学听一听他讲的话。现在有问题吗 ？OK， 理解 OK， 后面 OK 吗？有问题问再问，问到会为止，因为这个东西是大家都会的。So if there's something wrong, you have to ask. Okay, please make sure yourself know it, because I cannot make sure everyone know it. Okay. Okay, I try to, but it's very hard. So you only have to make sure yourself. So you make sure yourself have to know it. Okay, understand? I won't score you one. Okay, if you have a lot of questions. Okay, so B is the same. B is similar. You take any two elements in G prime, you prove that it commutes. So there's a writing problem from one of you. Let's show it now. You say that. So for every G prime in J prime, there is this P in J such that BP equal to P prime. And then for every Q prime in G prime, there is this Q in G such that PQ equals to Q prime. So then, so I want to write it here. Some unwanted, so unnecessary. How to name this 你们会受伤吗？很怕你们受伤，数学系学生很容易受伤。讲一点点，他就觉得好像我骂他这样。如果讲这个是 mistake， 你们会怎样吗？不会哈，我觉得你们班会比较好啊，其他班真的是你讲一点点不太好啊，他就恨你一辈子这样。OK， 我就算 mistake 啊。OK， so then OK， 什么问题？逻辑来说没有太大问题，但是呢，很好笑。有什么好笑啊？你们觉得很好笑啊？感觉这一句跟这句其实没有差别，你知道吗？这两个是在讲一样东西。你虽然换符号，它还是一种东西来的。You get what I mean? You're just really writing the same thing twice. You get what I mean? Because I don't care you put P prime, I can put X, put Y, put everything. Actually, these two mean the same things. Okay. What can you do in this case? How do you write better to prove it? 赵胜，你觉得应该怎么修改这个 proof？ 啊 ？comma？ You mean 把它放在旁边这样啊？放在旁边是不是？放旁边不？那跟我分开有什么差别？很可爱啊，很可爱的答案。修改的方法吗？你觉得？我教过啊，刚才开堂课就讲了，怎样 check for all，how to check for all。地方 ，how to check for all。We just started 20 minutes ago， 随便拿。So we really go and take it. Take any P prime Q prime in G prime. P prime and Q prime can be the same also. Can be different, can be the same. Don't care. Okay. We just fix two first. Fix 了这两个就代表我们有真的东西在用这了。把上面这个不知道你 fix 了没有，你也可以讲你有，我也可以讲你没有，看你会不会吧。你不会，你就是没有；你会，它就有。所以很 confused， 对不对？怎么办 ？Use this method. If you want to prove for all， 选出来一个一个检查就对了，每一只都给它抓出来检查。 有没有受伤 ？OK， pick any two of them and check， 对不对？因为你这样子用你很危险哦，我不知道等下你会不会用哦。你用一般用 confuse 去，或者你用错去。You understand or not? Okay. Another point here is, you see, this existence really depend what you had, really depend on what you had. This is what you have in your MA. For every epsilon, there exists a delta. That delta depend on what epsilon. If your epsilon 0.1, maybe your delta 0.2. If your epsilon 0.005, your delta will be maybe 0.0003, for example. So epsilon depend on delta. It's the same here. Okay, if you P a different P prime, Q prime, then there exists a different P and Q for them to be true. Does it make sense? 还是要我讲解一下 MA1 的 concept？ 看得到吗？你们 can you imagine this for all and that exists this kind of relationship or not? Like Jasmine, can you imagine how epsilon can depend on delta? Can you imagine? Cannot. Cannot. Maybe can. Can you explain? Okay, good. Very good. Okay. Yeah, very good. Okay. So I mean there's no point to write these two things out because they're really the same statement. Exactly the same 还不是很像，是完全一样，就是一样吧。I so no point to do this. But why can I do this? Because I fixed any two element already. I fixed two already. And then I start computing there. And then, 这是重点This is a very important So if you go do your same calculation here, okay, if you do this calculation here, and you said there exists P, Q, and G. Okay, last line here, since this is very important, P prime, Q prime are arbitrary, G prime is abelian. You see, this last line here is very important. 为什么mention？什么？然后呢，我证明了它这两个 commute。Then how I deduce that G prime is abelian？ 我只这两个罢了。Okay, since I check for any two arbitrary, so this line have to be important because for the first few line this is just only fixed for two. 我就检查两个罢了。怎么检查两个就可以讲全部啊 ？Yes, exactly. So these two are chosen arbitrary. Good, 非常好。Like the epsilon proof is also like that. You fix an epsilon greater than 0. Okay, and then the last line you say since epsilon is arbitrary. This line is very important. This line don't miss it. You cannot just start with any two and then you say that it's abelian. So it's very important. This kind of a small thing. Okay? So you might think that very redundant this line, but actually it's super important. Any question? 陆星有问题吗？因为我们随便取过后，它就被定下来了，它就是死的两个东西。我们只检查这两个东西，但问题是这个是随便取的，它才会被 extend 去所有的 cases， 明白？在检查 when we check this is really happening with these two elements。检查的时候就是这两个东西吧，但问题是我在检查这两个是任意的，明白？ 一定要知道这个差别哦，很重要哦。两个被选下来，那就是两个罢了。那问题是你怎么选这两个？它是任意的，这有两层关系，你们一定要知道。OK， very important 啊。因为如果你不知道这两层关系，不是很多的 mathematical statement 你们都会忽略掉，或者很多 assumption 你都会被。Okay, so I want to say that this line is very important. Okay. 还有其他人有问题吗？那边呢？那个是纸行嘛，青色页那个。这样一层带一层，对，听懂我说吗？什么？没在听啊？嗯，看那个 for all 是不一样的那个。for all 是说对于任意的两个 ，OK，take any two 是选定任意的，一个是你已经真的抽取两个了。啊，对，没错，因为会有危险，你会出错。因为有时候当你用 for all 的时候，可能你需要用到 the exist 的一些东西，但是这个 exist 的东西是 dependent on 每一个，对，然可能你需要用到这个特定的东西，然你就会出问题。对啊，对啊，所以我就选定啊，所以我选定啊。对，sorry，所以这选定呢，我们是用 subjectivity 了。为什么 subjectivity 可以用？Because whenever I have elements in G prime, I can find the pre-image。所以这个符合那个 subjectivity 的先决条件，然后我就可以找到 pre-image。OK 吗？因为每一个的 pre-image 可能长不一样。可能在这个情况不用紧啊，管你长怎么样，我都可以 permit。但是有时候呢，有情况是需要 depend on 它长怎么样，那你就要小心。OK， 所以最安全就是 if you want to prove for all, check one by one. OK, here we are checking 2 by 2. OK, but we still can do it arbitrarily. It could be the case that P prime equals to Q. But it doesn't matter because we are commuting inside the premesh. Within the premesh. OK? OK 吗？哦，就错例子啊。我要出错的例子哈。我可以回家想一想再回答你们。暂时没有想到。我回家想一下再告诉你，好不好 ？OK， 可以。还有什么吗？还有什么问题？也是 clear？I will read your argument. Okay, if your argument seems okay, I will let it pass. But if I feel that you are a bit fishy, you try to 可能大概这样，以为你 prove 到了，但我觉得可能会破分。那你就要过来跟我讨论了，为什么你这样写是对的？如果你讲得出，我可以给你分。OK，可能你只是写的问题吧，但是就是以后就要小心一点。OK，不然的话你会 confuse 别人。OK，还记得吗？我讲的数学是给最笨的人学的，说你的东西不可以 confuse 人。OK，人家一定是可以一行一字这样子的。啊，为什么我有这样的体会啊？哎，你们家里有买过新电器吗？ 有买过电器吗？新家里什么电器啊？冰箱 maybe fridge。冰箱里面有送一本很厚的东西，你知道吗？知道是什么吗？There's a user manual, very thick one。有人拿来读过吗 ？Have you read it？没有读哈，有人有读。But actually, it's very important, you know。你知道我妈吗？我妈，my mother, she got a new washing machine. She touched the button, get on， 洗不停哦。啊，关掉啊，直接关掉。对，他就做这件事情，他把插头关掉。She just removed the plug. Okay. Remove few times after, you know what happened? No， 还没有爆炸这样危险吗？ Then 那个 machine 就有一点缩缩了 ，gone crazy. But actually, I go back and read the manual. Maybe she just mistouched the setting. And then maybe just stop it is enough. If you simply plug the plug, then you destroy the circuit inside your washing machine. Okay. And then, in fact, I go and read the user manual. The user manual lists out every possible cases. Similar here, mathematics is like this. You need to list out all steps so that people can check and backtrack what you do is correct or not. Okay. Yeah. So if you found out that my note is not complete or my argument is not complete, you have to ask one. You have to ask me. Because sometimes I assume you know, or I assume I know. Okay, so you need to ask me and then I will write everything out. Okay, so make sure that when you read it, you understand. Okay. Okay, so this is question 1 about quantifier. How about question 2? I think question 2, all of you did a good job. You said ABCD and then you try to find out what is a possible ABCD here. So what do you need to make sure? So first question, you need to be conjugate under GL2. So you need to make sure that the determinant is non-zero. And then second case is SL2. You need to make sure that the determinant is 1. Okay. So there's one pattern you got it. It's either 0, B, B, B plus D, or I think some of you get B plus D, B, B, 0. The determinant of this matrix is just minus B squared. So you just need to make sure that minus B squared is not 0. Then you can get your G that help you to conjugate your matrix. So meaning what? Actually, they are conjugate with infinitely many choices, okay, as long as B is not 0. But can you make sure that minus B squared equals to 1 in real? You cannot, right? You only have B equals to complex number I. Okay, but complex number I is not in the real number. So they are not conjugate in SL2. Three, prove that K is normal and then the intersection is normal also. So, I mean, some of you prove subgroup again. Actually, you can use whatever we did in assignment and whatever we did in lecture. You can just quote them. But if in the exam, I ask you to prove again, then you need to do it. Okay, otherwise you can just use it. Okay, you can just use whatever we prove in lecture, assignment. Okay. Okay, so for this question, I think normal is quite easy for you guys. How about finding counterexample? So what's this counterexample asking? You know? 来问问郑月. What's this first counterexample asking? So what's the difference between this statement and the previous statement that you have proven? Mm-hmm. Okay. So, mm-hmm. Good. Okay. So you only show that this intersection is normal inside a smaller group H. But it asks the question whether if you put it back to G, is it still normal or not? Okay, so the answer is no. Okay, so you can find it in X4 or you can find it in matrices also can. But make sure you want to find not normal group, don't go abelian group and find it. Why not? Abelian group is always normal. Okay. Actually, they commute on the knots, on the elements already. Right. How about second one? Second one says that if you remove the normality of K, do you still get this normal subgroup property or not? I mean, quite obvious, maybe it's no, right? Okay. So what do you do? I think most of you give a very simple example. You just take G, H to be G, and then just take a not normal subgroup. Okay, intersect with your group. But in here, you can also check that these two non-trivial subgroup here intersect to get a non-trivial normal group. Non-trivial normal group, right? Can normal group be trivial or not? Is a trivial subgroup a normal group? Is trivial subgroup a normal group or not? 小叶旁边那个叫啥？同学，你名字叫什么？孙佳怡。Okay, 孙佳怡。Is a trivial subgroup a normal group or not? No. You think no? 小叶呢？ Maybe yes. You maybe 对不对 ？Yes or no 吧？哦，数学就 yes or no。你觉得 yes 还是 no？ 啊？什么 ？Yes 啊？Why？ To prove normal, what do you need to prove? What's the definition of normal? 冰箱旁边那个叫什么？周一凡来 ，What's the definition of normal subgroup？ 啊？Normal subgroup 你要检查什么 ？If H is normal。有没有 lecture note？ 检查一下，赶紧找一下。随便你问到。Albert，what's the definition of a normal subgroup? If H is normal, what do you need to check? Sorry? No. What's the definition of a normal subgroup? Quickly check. 红瑞旁边那个叫什么？嘉怡，来王嘉怡，然后那边是孙嘉怡，是孙嘉怡吗 ？OK， 好，王嘉怡。What's the definition of a normal subgroup? 你先说说看。OK, I mean, let me think. 存在是 exist 还是 for all？ 你要检查 for all 啊。 先写下来先。这下去检查看有没有讲错。有没有讲错？检查一下，检查一下 definition。For all G or there is G. For all right, okay. Actually 也要 for all 哦，每一个很强的 ，okay 很强 ，okay quite strong. For all 啊，you need to check for all. Okay. So if your H is trivial, meaning what? G inverse is what? Still E. This is true for all G. Okay, so G is just G inverse is just E. Okay. So it's always normal. Okay, don't look for this trivial case. So that's how we say this group is trivial. A lot of property it satisfy trivially. Okay. 来，孙佳怡，知道为什么它不 normal 吗？为什么 trivial subgroup not normal？因为 G inverse 你又拿回你自己，所以它一定是 normal。OK 吗？看得到吗 ？OK。Yeah. So this is always normal. Okay. Okay. Four a bit tricky. Before the due time, I put positive, right? If it is 0, then nothing to do. So if it's positive means what? What's the possible case? It could be either p squared, p true, and so on. Okay. So what's the claim here? The claim here is you go find an element with power p to the something. Okay, p to the some positive power here. And then you just reduce by 1. This will be the element that has order p. Okay. So you need to argue why this element has order p. Because the order of this element here must be less than or equals to p. Okay, but if it is less than equal to p, what happens? You actually assume that this element has order PR first. Okay. Then anything less than PR cannot be the order. Okay, then you are done. Yeah. So maybe you will ask a question. How do I get this element with order PR? How do I get? Because I must exist some element which is not the identity. Okay. If you have this element not equal to identity, meaning what? The order of this x must divide p to the r. Okay, must divide p to the r. And then what's this r here? Okay, maybe not confusing you. This r here should be less than or equal to the order of your g. Okay, so this r here could be less than equal to f and greater or equal to 1. Okay, for some that exists. Okay, very important quantifier. Then the claim is x to the PR minus 1 is the order p element. Why? Because if the order is less than p, then you will get this element here equals to identity earlier than p to the r. Okay, so there's a contradiction here. Any question? Some of you caught what Cauchy's theorem. I didn't know this is a Cauchy's theorem, but some of you caught a theorem. But we never did it in class. So you have to prove it. To prove it is exactly the same thing you do here. Yeah. Right. Okay, last one. So part A, you want to show that the intersection of two cosets is either empty or a coset of a subgroup of H intersect K. So empty is natural because whenever you intersect two things, it could be empty. But if it is not empty, then you want to show that it's another coset. Okay, coset of a different subgroup now. What's that subgroup? Is the intersection of the two subgroups. But how do I prove it? So I make an equivalent statement here. Let's see what I wrote. So this equivalent to prove that if A is equal to B, if AH equal to B for some H in H and AK equal to B for some K in K, then A is equal to B if AX equal to B for some X in H intersect K. Okay, so what do I write here? We realize coset as an equivalence relation. Okay, this is what we did last time. Correct or not? Because through this equivalence relation, we get our partition. Okay, we use coset to partition ourselves. But how to prove this? You can write, what can you write here? So what do I need to do here? I need to just find X. I need to find X that works. Okay, find X that works. So how to find this X? So you already know that you can write B as AH and then B as AK for some H and K. But can you write B as A of some X in the intersection or not? So what do I do here? What I do here was I just equate these two. What do I do here? So let's see. So this implies that AH equals to AK. But what is AH equals to AK? By cancellation law, you know that H equals to K. Okay, H equals to K. So really, H equals to K. But if H equals to K, meaning what? H is in H. H is also in K. K equals to H. K is in K. K is also in. So what's the X you should pick here? You just pick either H or K. They are the same. Okay, just choose S to be H or K. Yeah, so this is a quicker way. What do you do? Yeah, I mean, yeah. What do you guys do? Oh, you right. Yeah, right. You correct. Correct. So what you do is normally you guys do this. You do equals to G of H intersect K. How do you pick this G here? You pick the G from the intersection. Okay, so this is what you do. Some of you even do better. Even better. You can actually quickly write these as GH intersect GK, which is good. Because this tells you how to solve the next part. Then you have this equality here. Next part is easy to see already. Why is it easy to see? Next part asks about what? You want to show that H intersect K has a finite index. Okay. But what did this equality tells you? How do you get the left coset of G intersect K? You just do GH intersect GK. Okay. But what do you know about the index of H and K? They are finite. So you just look at finitely many intersections. Okay, so you just look at finitely intersection. So you know that this left-hand side here is finite. Not only you know that the finiteness, right? It is at most how many? At most the index of h times index of k. At most. Because sometimes you get empty intersection. Does it make sense? Okay, so if you prove this, this is very good because it straight away tells you that how do you get the left coset of h intersect? It's exactly you do GH intersect GK. Okay. And do you guys know how to picture these? Do you guys know how to picture this? Do you know how to draw it? This intersection coset here. Do you know how to draw it? 会画吗？我怎样把它画出来？不会。我班上不是有教怎么画 group？ 通常我们画个圆啊，对不对 ？Okay, so let's say you have a way to cut it into H, AH, BH, CH. K, maybe K cut like this way. How about this way? K, and then do we still have AK? Maybe have other things. EK, FK, and GK. So how do you take intersection? Well, you just put them together, intersect it. So how about I make it a different color? Like this. So where's the subgroup K intersect H? 看下有人能够指出来吗？雨轩后面那个蓝色衣服叫什么名？子豪啊，子豪，子航，OK 。哦，曾子航哈。Okay, so in this picture, where is K intersect H? K intersect H 在哪里？在这个照片里面。不知道。有看到颜色的差别吗？蓝色跟红色看得到吗？看得到吗 ？Okay, so K is here, and then H is here. So where is K intersect H? 知道吗？看不出。子涵旁边那个呢？叫什么名？是 ，sorry 听不到。哦，刘金鹏。Okay, do you know where is K intersect H? 不知道，知道 K 在哪里吗？有4个格给你选。啊 ，K 在哪里 ？K 在哪里？上下左右选一个。上 ，good。So K is at the top。子涵选 H 呢 ？First quadrant, second quadrant, or third quadrant? First, second, third, fourth 哪一个 ？H。1、2、3、4选一个。看不到没？我已经放最大了。1、2、3、4选一个。对，知道怎样摆1、2、3、4吗？1在这边，2在这边，3在这边，4在这边，选一个。H 哦，认不出这个 H，这个是 H，然后这一是 AH，这个 BH，哎，这 CH，sorry，CH，这个 BH，所以 H 在哪里？哪一个位置？2是 BH，再 try 一次，还剩下3个选择，比较简单了哎，这次刚才4个嘛，1、3、4再选一个，认得出吗？还是你认得出这个蓝色字母吗？看不出，看不清啊？ 没戴眼镜？为什么不戴？没戴眼镜坐这么远，打算不看是吗？下次记得戴眼镜哎。修着 I where is H? E. Good. Okay, so where's the intersection here? So intersection live in here. So this part is H intercept. Okay. Okay, then you can form your coset. Okay, not. Okay, so you can see that there is like how many coset here? 1, 2, 3, 4, 5, 6, 7, 8, like that. But the possibility tells you how many? 4 times 4, 16. So actually in this case, it's 8. 少留一半。这个才可以到16个 because you take random intersection. So maybe you take this maybe you take this part here and then go intersect this part here. But from this picture, you can see that they are disjoint. From the partition, you should see that they are disjoint already. Okay, because in part A is a random one, x and y random for all x and for all y. But if you look at this one intersect with the other coset, should be empty because partition. Oh, yeah. So I think there's another thing, another way you draw it. Maybe there's some case like this. Okay, you can cut it like this. Okay, maybe right. I think this is what Seng do, right? AKBK. And then what's the other way to cut it? Maybe you can slice like this. Right? How to slice like this? Maybe H. Right? H and then B. Not B lah. Use other one. CH. And then FH. Okay. Maybe you can got all of them. Possibly. Okay, so depend on how you partition. So in this case here is 3 by 3, right? If the all intersection is non-empty lah. Okay, if empty, you still reduce it. Okay, if it's non-empty, then you have 9 total, which is 3 times 3 maximum. Okay. Right. So far, any question for this assignment? This assignment is not as long as the previous one. Just that some concept statement that you need to be aware of. Okay. Any question? 有问题吗？和你做 assignment 的时候做答案一样吗？一样吗？不一样。Concept 咩 ？Concept 一样吗？ Is it the same as when you do it? Do you understand better? If not, you have to come and ask me. Tomorrow got office hour also. Oh, tomorrow still, this week still have, it's next week. Next Tuesday, there will be no, I won't be in the office because there's a calculus 2 exam taking part at 2 to 4 next Tuesday. But some of you say you want to use the office room. Do you want to use it or not? Then you can go and stay there and do your homework because some of the seniors say they can be there. So if you want to ask them, also can. But I won't be there next Tuesday. There's an exam going on. Wednesday, we can keep going because Thursday we have exam next Thursday. Okay, yeah. Right. Should we continue? We continue? 还有什么问题要问吗？ Any, you have tried the arting solution or not? Or you want to go through the practice exam question? Practice exam question. So let me bring it up. Okay. Have you tried these 4 questions here? Do you understand what you need to do? If you still cannot see, please download. You can download from Moodle. Moodle got this. Okay, this is the largest we can go. Anyone look at test question yet? 红瑞做了吗？红瑞做啦，做完啦。OK， 你觉得怎么样？难吗？还可以。OK， 你的同学在用怀疑的眼神看着你。OK，anyway，so 第一 when you read this question, make sure you understand what's the question asking. Okay, Jasmine, do you know what the first question asking? What do you need to prove here? What do you need to decide? Something you prove or false. English, how do you break down long sentences? 去找 verb, where is your 动词? Okay, and then what's in front the 动词? And what is behind the verb? What's in front of the verb? What's behind of the verb? Okay. So just asking you whether a set is a subgroup or not. To talk about subgroup, you need to talk about group. So this is a subgroup of GL2. What's GL2R? Invertible matrices, 2 by 2 invertible matrices. And I quantify something. I quantify the lambda. Meaning what? For every lambda, it has to be a subgroup. True or false? If it is false, what do you need to do? Counterexample. What sort of counterexample you need to produce? Can you tell me the strategy? You need to produce what first? You need to show a for all segment is false. You need to find a no. You need to find what? A lambda such that that set is not a subgroup. Okay, so can you do that or not? You can. How? Can you choose lambda to be 0 or not? Ah, right. Here comes this notation problem here. A lot of you write z plus like this. I know you meant z greater or greater than 0. But in this course, I not recommend you use this. Because plus for us is a LOC. Later you're confused. Plus is a LOC. In particular, this one, what is this? R cross. Then later you confuse with R plus. R team use R plus, if I'm not wrong. So please don't use Z plus in this course. Maybe you use the other course, but we have LOC here. So what kind of plus? It's not just positive, we have addition. Okay, so if you want, use this very obvious one. You include everything greater than 0. Okay, so what's this XR plus, R cross? Still remember this notation? Multiplicative group. Meaning what? All the element that is invertible. So you cannot pick 0 already. So what else you can pick? 2. Dawson said 2. So you want to show that it's not subgroup. If it's not subgroup, which condition you can violate? Got 3 ma? Correct, not subgroup. Closeness, inverse, and then identity. You want to try closeness. Okay, how to try closeness? Take 2 elements in H with determinant equals to 2. And then you want to compute whether AB is still in the set or not. But we know that determinant of AB equals to what? In this case is 4. So you leave outside the group. Okay, so it's not close. Identity also easy to show. Is identity easy to show? Y identity is not in there. Determinant of identity is 1. Okay, identity is also not in H, since determinant of identity is 1, not 2. Sorry, not close. Okay. So first question is false. So make sure you write false and true, and then you either you prove it, either you give counter example, depend on what question is asking. B, number 2, number 3, number 4, you guys okay or not? Or do we need to run through them? I think the hardest one, when I said this, I think the hardest one is 4. I said it. 4做过了。2、3有做过。When did you do it? Oh, yeah. Assignment got. Yes, exactly. 3, I mean, number 3, I sort of mentioned in the class, and then I left as exercises. So be careful, those exercises might come out in the exam. Make sure you try. So we try hard, okay, to produce the typeset one before this, I mean, during the weekend, so that you can have at least 4 days to look at it. And then that typeset lecture notes will contain solution to some exercises, okay, to help you to check the homework that I left you to do. Okay. But if you found any mistake, please contact us. Don't keep it yourself. Just contact us. Okay, 2 and 3 may be obvious. Okay, if it is obvious, can you tell me what's the true value for 2 and 3? 2 and 3. Question 2, true or false? Statement 2, true or false? Eugene? True or false? True or false? True. You prove it. If it's true, what do you need to do? You need to show the 3 property. Inverse is in there or not? Identity is in there or not? Is it close or not? Okay. I think you have problem showing closeness. How do you argue that everything in X, in everything in A, everything in B, when you multiply them is in the union? Why? Not necessary. Okay, if you don't believe, just now I just said false, right? It's done in the assignment. Can you give a counter example? Yeah. So look at Z, and then look at the subgroup 2Z and 3Z. Okay, so why is the 2Z union 3Z is not a subgroup? Why is it not closed in this case? Identity must have one, because both of them are subgroup. Inverses also have, because both of them are subgroup. Why not closer? What's the 2 element you add inside here will go outside the union? You can take 5, which is equals to 2 plus 3, but 2 is in 2Z, 3 is in 3Z, but 5 is not in the union. It's not a multiple of 2, it's not multiple of 3. Understand? 明白吗? Okay. Okay. Question 3 is true. You need to show it, like how we did associativity class. 4 is kind of hard when I gave it last time. But true or false? Question 4. True. Why? Why is it cyclic? What's the generator? Good. How do you prove this? How do you prove? You need to prove what? Cannot say we prove in class because I asked you to prove now in this case. Yihang, you know how to prove how 1 generates Z? Yes. So if you take any element inside Z, so you just add 1 n times. Okay, so this is the proof. Okay. Yeah. You write every element as a power of your generator. That's all what you need to do. Okay. So I mean, if you like, I write like this, add n times. Okay. Good. This one, this is kind of a fun game here. I think I won't show it here, but if I give you this statement, right, how are you going to prove it? If and only if statement. I see the how to prove an if and only if statement. Yeah, prove if and only. So let me draw something. So 这样子看，这样子看，这样子看。P if and only if Q. So what do you need to do here? If you prove an if and only if statement. How many directions you need to do? 2. Where to where? P implies Q and Q implies P. Good. So if you want to do P implies Q, what do you need to do? What do you need to do? You need to prove 2 segments, right? H is not empty, and whenever A and B is in H, then AB inverse is in H. Okay? Good. So 2 things you need to prove. Why is it not empty? If it's subgroup, good. Your subgroup must contain at least an identity element. Okay. Whenever AB is in H, why is it AB inverse is in H? Because A is in H, B is also in H. B inverse in H. Why? Because H is a subgroup. And then you take the closure is still inside the subgroup. Okay, so actually P to Q is easy. I think the hard one is Q to P. Okay, so Q to P, you need to prove what? Identity is in there. How to find identity? Okay, how to find identity? And then how to prove inverses as this? How to prove closeness? Only from this AB inverses in H. Let's do identity first. How to find identity? If I tell you anything inside H, AB inverse is in there. How do you get the A first? How do you start with an A? Because your H is non-empty. So meaning there's one thing inside there. I don't know whether that thing is identity or not, but I can use A and A inverse. Does it make sense? So meaning the B there is applied to A again. So, right, A inverse is the identity, and then what else do I need to show? Inverses. Inverses, how to show? If A is in there, A inverse, why is it in there? You can write A inverse as identity times A inverse. Okay. So I already know that A is in there. Identity, I prove that it's in there. So I just use A equals to identity, B equals to A. So E times A inverse is A. Okay. Closure. If A, B is in there, why A times B is in there? Because I proved that A is in there, if B is in there, B inverse also in there. So I can apply this condition to A and B inverse so that A times B inverse to the inverse is in H. But B inverse to the inverse is what? B. So AB is in H. Okay, so if you cannot follow, I have solution. Go and try it out first. Don't remember solution, no use one. You need to try and figure out. Play around. Okay, play around. Play around with this definition. First, you need to understand what the question asks for. Okay, this one. Prove that this map is an automorphism. I also think that this question is quite hard last time. But this is one of the things we did in classes. Okay. So I want to show that this map is an automorphism. So what's this map? This map is a conjugation map. Okay, conjugate by a G element. What's automorphism? Maybe there's one thing you need to include in the cheat sheet. What's automorphism? A morphism to itself, okay, and then in particular it is a homomorphism, and then it is an isomorphism. Okay, so there are a few things you need to check. Homomorphism and then isomorphism. Isomorphism got how many things to check? By bijection, good. So you check homomorphism, and then you check injectivity and surjectivity. Okay, so these are the things you check. So in the exam, you say, I cannot produce all the proof, but at least you tell me these, maybe you can get 2 or 3 marks like that. Okay, you need to tell me how to do it. You are 步骤分很重要啊. Okay, 步骤. If your step is wrong, then most probably you have no marks. So, but if your step is correct, but your calculation wrong, then you will get partial marks. Okay or not? Okay. Even if you tell me what to prove, maybe you got 1 mark. Okay, what to show, what to show. If you state the right thing to show, you got 1 mark. Okay, 这些分不是可怜你啊，你知道吗？这些分exactly tells you how to proceed， 对吗？你要写完整个答案，你第一行就要对了，你就要知道你证明什么，那个就有分了，就开始有赚分了。And then 你又把你的 goal 换成 concrete 的 goal， 3个东西你要证，哎，更多分了。怎么 earn 完 all the marks? You need to do all the things I ask you to do. Do you know homomorphism property? Okay. Do you know how to show injectivity? Equals to Vy implies x equals to y. Do you know how to show surjectivity? Okay, 如果能，满分就是你的了。Okay. Okay, quite simple. Just that every step you need to know how you get it. Okay. Oh, this is about this. See, the question, the answer also not long. Yeah. 你不要想太长啊，答案不用太长的，没有很长。只要你写的对就可以。How do I do this bijection? I don't use injectivity or surjectivity. What I use the inverse. I go and find the inverse. Okay, so there's 2 directions I check. You can do injective, surjective. It's okay. Or maybe you practice your injective, surjective. Okay, 4. Prove a TFAE statement. The following are equivalent. Okay, what do you do? TFAE, 直线. What do you need to do if you want to prove a TFAE statement here? 读都不用读哦，这些 statement 都不用读，你就应该要知道做什么。TFAE statement. What do you need to do? There are three statements here. Okay, so you need to produce a cycle between them. Okay, maybe you can choose 1 to 2, 2 to 3, and then 3 to 1. This is only one way. You can use the other way, right? What else you can try? 1 to, sorry, 3, and then 3 to 2, and then 2 back to 1. Still got other way, right? What else you can do? Start with 2, and then 2 to 1. It's the same. This one is the same of this. This is the same cycle. You learn SN, right? This is the same cycle. You just write 1, 3, 2, then you write 2, 1, 3 only. It's the same cycle. How about don't play around with cycle anymore? What else you can do? Sorry? Good. So you have a if and only if statement, and then okay, so you want to do the other way around, also can. So this also form a cycle, right? Can you see it? So you can go from one number to the other number using the both way direction. Okay. Okay. Yeah. So you can try all these. How you go around with these. So this one, I think it's quite simple. You just play around with your cancellation law. Because everything live in a group. Freely use the inverses. Okay. Free to use inverses. Okay. Yeah, you see, the answer is like this. Very simple. 不要想太复杂，考试问自己要什么 definition 是什么，写一写答案就出来了。OK 吗？不要自己乱啊，不要自己看到，哦呦，这题没有看过啊，就乱了。那个字肯定你看过啊，只是那个组合你没有看过吧。So go and find the definition first. Make sure you know what to check. 这题I think 很像assignment 的。Prove that left inverse equals to right inverse. In the assignment, I ask you to do left identity equals to right identity. Okay. 不知道，忘记了，交了，已经忘了。Okay, I think this one don't discuss. So the solution is like this. Very similar to your assignment question. You want to show left equals to right. So you start from anywhere, start left or start right, and then equal. Okay, so what have I used here? I just use identity elements, and then I use the definition of left and right inverse, and then I use associativity. That's all. Okay. 6 easy calculation. I can confirm you. You must know how to calculate. There's one question on this. You must know how to calculate this cycle. Okay, I can confirm you. There's one question on this. You need to measure. You need to make sure you know how to compute this cycle thingy. Okay, don't 不要粗心啊 You have to compute right. 你看很严重哦，一错4分就不见完了。Unless you give some nice working for me to check. If you just write down an answer which is wrong, then you pretty much gone this form. Right. 其实 the killer the killer of this this midterm paper is this question here. This question. The more specific killer is this one. I set this as a distinction mark question. I wouldn't say this A is hard because I already asked you, I give you the map to check already. Even if you don't understand what this question asking, go and check this. You get more of the mark already. Just that you need to argue why after I prove this, you have a number right coset equals to a left coset. Okay, let's ask you, if I give you this map, do you know how to check well-definers? 还记得什么是 well-definers? Well-definers is the converse of your injectivity. Good. Okay, so if x equals to y, Vx equals to Vy. So in this case here, what's the statement? If G1H equals to G2H, you need to show that phi of G1H equals to phi of G2H. Even if you don't know how to show this, you get 1 or 2 marks already. You know how to progress. Okay, how to get all the marks? 走完这条路，走完这条路 continue and walk. So by definition, this is what? HG1 inverse equals to HG2 inverse. So the question is, why is this true? Is this true? Why is this true? So this is true if and only if what? H equals to H2 inverse G1. Is this true? When is this true? This is true if G2 inverse G1 is in H. This is true if and only if G1 is in the same left coset of G2. Do you have this is true? Is G1 in the left coset? Why? The TFAE on the left coset. Because you can see that if I apply G1 to identity, this is, you can write as a G2 of some H. Okay, so meaning G1 live in G2H. So by the TFAE, I mean, not only TFAE also, you already have this condition. Actually, the TFAE, I use it here. I use it here. Okay, yeah. So you see, I work backward. 我从后面做上去. Obviously, you need to write the other way around for me. Okay, so this is your working. Okay, so I'm working backward. So working backward. So make sure you write. So PS, you need to write forward. Hey, you all taught by do lead, right? Do lead 就是每次考一个 epsilon delta proof and then 你要写2个答案出来，是不是？一个是 scratch word， 一个是对答案，是不是？ So this is what I meant here. So what I wrote here is a scratch word. So you need to write forward. Okay, I work backward. You need to write forward. So this is the thing you need to write forward. Okay. Else. Okay, and then you need to check injectivity is the same surjectivity. You see, this thing very important. Make sure you know. B. OK， 假设给你这个 B 哦，你知道要做什么吗？有 idea 吗？没有 idea 的话，在我班你需要画。画。怎么画 ？Index two 哦，会画吗 ？Index two 的 group 会画吗？就一般吧。所以一个是 H， 一个是 AH。H and H。How to show H is a normal subgroup? You want to show that GH, G inverse. The equivalent definition is what? Equals to H. Not just subset, or you can actually show it is equal. I do in lecture note already. But what? But what? But what? Come on. But what? Should I use A? Peter. But what? There are few ways to approach this. There are few ways. So, I mean, if you use these question, how many? Hey, where did we show the automorphism thingy? Question what? This automorphism here. GHG inverse is what? Is H. Sorry, is H or not? Well, I think it's not. But what we can do is, it is a, so okay, so let me use this first. So if you find on the H here, phi g of H is what? It's an image of this automorphism, meaning it is a subgroup. It's a subgroup again. But in this case here, you index is 2. The index is 2 means what? This is a subgroup, and then can this be a subgroup again? No, right? Because identity is not in there. So if you are another subgroup, you have to equal to H. So it's normal. 10分送给你了，就这样。啊？讲什么？讲多一次。Okay. So just now we proved that. So from question 4, we know that phi g of this map here is what? Is an automorphism. Meaning it's a homomorphism, right? Morphism. So you can look at the image of the subgroup. So we prove what? We prove in class what? Image of a image of a group under homomorphism is what? It's still a subgroup. Okay, it's still a subgroup. But but if you look at this group here, if you look at this partition here, where's the group? There's only one group you can belong to. Okay, make sense or not? Does it make sense? No. Why? 画什么 ？H 里面有什么？小圈圈是什么？What do you mean? What do you mean? Elementing. Huh? So I wait. So I want to claim that this GHG inverse is equal to H. Can I claim that? 不知道，不够啊？你觉得不够 ？You think not enough? Well, I mean, okay. So okay, if you think that not enough, what do we need to do? We need to at least show that this intersection is not empty first. They have something in common. If there's something in common under this partition, they have to be the same thing. Okay, so what is inside phi g, phi h here? Right here. I claim that there's identity inside here. 有吗？这 image 有没有 identity? Where do I get the identity? I just take E conjugate with the G, because H is a subgroup. So GH. So okay, maybe I use. Okay, let's move everything outward first. So we see that phi GH intersect H. This is just GH inverse. Is what? Is equals to. Let's write this. Is equals to identity. Okay, no, contain. Okay, contain identity. Okay, so under this partition, they have to be the same. Okay. Partition means what? partitions 不知道这个 concept。If you have a partition, because their intersection is not empty, so whenever you found another set that has a non-empty intersection with one of the partition, it has to be equal to that partition. 不明白，这个不明白。为什么哈？为什么是不是 ？So I need to verify 咯。How to verify this sentence here? You need to show that identity is inside hash, identity is inside the image. Okay. Hash is a subgroup, so it has a identity. But why image also got a got identity? You can create it using the GE G inverse. It 就不是 destroy. It's not destroy. Okay, it's not destroy. OK 吗？ Yeah， 有问题吗？看没有问题啊？没有。看一下我有用什么其他做法吗 ？OK，use part A. How to use part A? So I use this fact here. A subgroup is normal if only if every left coset is a right coset. 我没有 proof 过吗？这个有啊？有吗？啊？号码？号码？什么号码？有是不是 ？OK，lecture 几啊？12啊？OK，有 lecture notes 有。OK，so right. So if left coset equals to right coset, how we use it? If hash has an index 2, there's only 2 coset here. Similarly, there are only 2 right coset. So we break this into two-way hash union G1 hash union hash G2. But what? But since the coset partition G, meaning what? G1 hash has to be equal to hash G2. Because hash cannot be equal to hash G2. Because hash G2 don't have identity. It's not a subgroup. Okay. Okay or not? So I mean this feature says what? If you have 2 ways to cut your G, right? So maybe you cut it like this. Can you cut it like this? 有可能吗？你觉得有可能吗？ You think possible or not? This is the same G. Cannot, huh? So because hash is not changing, right? Okay, because hash is not changing. So you should cut it the same way. But this implies what? This implies what? Everything inside G hash 1 should be everything inside hash G2. Okay, then you use this condition. Okay. Okay, so this condition actually very strong. 这个 TFAE statement 吗？那边我们 prove 的时候是 TFAE 吗？第二个 TFAE 是吗？ Or is the second TFAE statement you need to be aware of. Okay, so this TFAE statement is very useful. So don't undermine them. Okay. Yeah. Okay, so the whole thing is very short one. Just that whether you know how to put the concept together or not. Any question you want to ask? Any concept you want to run through or not? Any concept you want to run through? You think that Shaky don't understand? 有吗？有吗？黄山的 theorem or any definition you want to see more example? 该是子豪啊， 如果你说 for all 的话，会有出什么问题？有时候，OK，我会去想一想，可能我改一改，答案就会出来。还有吗？还有其他你要求的吗？Any requests？是吧？Any requests？ Anything you're not sure what I'm talking about in the class? We can briefly run through now. 全部都明白了，100分。没有，不是要有问题呢？如果没有的话，用拍谁啦？你还了学费了。Jasmine, got question? Sorry? Got a lot. One by one, cannot, maybe cannot all, but one by one can. Right? Oh, Kelly's theorem. Okay, what's about Kelly's theorem? Don't understand the proof, huh? Or don't understand the proof? Okay. If we go about this proof, is quite long. Which part you don't understand? Whole thing. Maybe specific a bit. Try specific down. What's the problem? You don't know. Maybe it's notation or maybe it's concept. Concept, huh? Okay, we can narrow down a bit. If the concept is don't understand, which line you don't get it? We need to narrow down. Okay, we need to study using science, 科学学习. So we need to narrow down. Which line you don't understand? What? Which part? Or the whole thing, what to do? Nothing to prove, I just define it. Continue. I just call it a name. That map has a name. That's all. Yeah. And then prove that this map is one-to-one and only. Oh, wait. Sorry. There are two things here. So one is I define this map. So to define this map, I need to define the image first. So what's the thing I need to check here? I need to check that this map is injective and homomorphism. And then I need to check that this image is the right thing to stay inside SG. So to stay inside SG, I need to show that lambda x is a bijection. So there are at least two things to do here. So one is about phi, one is about lambda x. Okay? I understand or not? Lambda x is what? Okay, it's what? Lambda x is another map. Okay, lambda x is another map. So what's this map? This map is you give me anything inside G, I send it to SG, XG. Okay, and then I have to show that this lambda x is a permutation first. But permutation just means what? A bijection. Okay, so I need to show one-to-one and onto for this lambda x first. And then I show that phi is a homomorphism. And then I show that phi is injective. Okay, so when it is injective, it is inject as a subgroup because we prove that homomorphism of a group, image of a group under homomorphism is a subgroup. Okay, so that's all we proved. And then you need to follow in details. So how do we show that this phi is a homomorphism here, and then why this phi is injective? Okay, you get the whole picture now. Okay, after you get the whole picture, only then you go and see how I do all these things. Okay, whole picture is very important before you get these working out. Because once you have a whole picture, all these long proof, you will automatically write it out. Okay, if you don't have it, if you remember one by one, very hard to construct this proof. Okay, but the whole picture is showing two things only. This phi is an injective homomorphism. Two things you need to do. This lambda x is a bijection. Two things you need to do. So together got four things you need to do. And so you can see that there, 1, 2, and then 3, 4. Okay, four things you need to do. Yeah, any more question? More question? Yeah, okay. 1000呢？100分？输了？有没有问题？你打 lecture 都有心得吗？还是你只是画吧？你是负责画的？你画了，有没有心得？有没有画了过后，好像忽然间看到一些东西我没有讲到，还是没有听过？有啊，对。其他有问题吗？雨金什么？什么？单词没问题。嗯，雨金，你读东西要仔细一点，我建议。对，不然的话你会看漏很多东西，蛮重要的。比如说我改的那些 assignment 呢，跟你画起来、圈起来那些地方，如果你不明白，你一定要来问我。然后你一定要记得把那些洞填，不然的话你下次还是会 miss 掉那个洞的。OK，因为有时候我看到你会读错题目，那个会比较严重一点。因为读错题目就基本上就是不对了，然后还有一些漏掉的地方就要小心一点。Albert, have any question? No. No question. Two things. Either you understand everything, either you don't understand everything. So very dangerous. So if you read, you can come to office hours now. Okay. Rosin，还没复习完。彭瑞，你有做吗？有 try 做 extra 练习吗？Sorry，4到8全部做完了。OK，可以明天来找我。OK，明天来找我。可以放学了吗？你们要走了吗？是还是没有吃？ 怎么可能到9点才完？OK， 全部人要走吗？啊？还没要走可以先走啊，有人要留吗？没有人要问东西啊？我是遇到10点啊，如果你们还问的话，你们要走是可以走的。OK， 要走是可以走。但是如果你们还有东西要问，到10点我是还 OK 啊，因为这个地方定到10点，如果没有就你们就要回去准备你们考试哦。